To move artificial intelligence from a text generator to an active tool, we have to let it out of the chat box. An AI model needs to reach out and operate the external folders and server racks that run our daily workloads. Giving an AI a set of digital hands introduces a direct engineering debate. We have to decide how to connect the model to those external tools, through unrestricted raw commands or through highly structured protocols. The first option is the command line interface, or CLI. This is the terminal where the AI types the same standard commands a human developer uses to navigate a system. Granting this access upgrades the AI from a passive responder into an active agent that can manipulate files and execute code. This immediately forces developers to balance the agent's autonomy against the need for predictable control. Large language models understand CLI commands natively. Their training data includes millions of pages of coding forums, Stack Overflow posts, and technical manuals. This knowledge acts like an instinct. An AI can concatenate a file or run a search command immediately without requiring any extra instructions on how those tools function. The alternative is the Model Context Protocol, or MCP. This is an organized control system where tools are hosted on dedicated servers. In this architecture, an AI node connects to a server that exposes specific tools. Unlike the command line, every tool is defined by a rigid JSON schema that dictates the exact inputs the model must provide. Developers are left with a choice: rely on the AI's built-in command instinct, or require the model to read a strict operational manual for every action it takes. That operational manual carries a token cost. Loading an AI with explicit instructions consumes the model's limited memory before any work begins. When using MCP, the complete JSON schema for every available tool must be loaded into the AI's context window. The official GitHub MCP server illustrates this overhead. It ships with 80 distinct tool definitions. Loading those 80 schemas burns approximately 55,000 tokens. For local tools like Git, MCP applies a steep financial and memory tax to teach the AI a set of commands it already knows. However, the command line instinct has a breaking point. Consider an agent attempting to read a modern web page using only terminal commands. The AI will likely use a basic command to fetch the raw HTML. But if the site is a modern Next.js application, the server doesn't send a finished page. Instead, the command returns a pile of unrendered JavaScript code. Standard terminal tools cannot render this, leaving the AI with a skeleton of framework code rather than readable text. The agent then enters a downward spiral, burning thousands of tokens writing custom Python scripts to reverse engineer the framework's internal data just to find a single paragraph. When a task requires more than what a raw command provides, the AI's CLI instinct becomes a disastrous liability. This is where MCP provides a solution. An MCP server equipped with a headless browser can render the page itself. The server extracts clean text and hands it to the AI, finishing the task in seconds with minimal token usage. This abstraction is necessary for enterprise operations. Interacting with a secure database or Slack channel requires managing OAuth tokens, verifying channel IDs, and creating audit trails. MCP manages the heavy abstractions and organizational governance that raw terminal commands cannot securely support. Effective AI agents do not treat CLI and MCP as an either-or choice. They use a hybrid workflow, evaluating the complexity of a task before selecting the appropriate interface. The system routes simple tasks to the CLI when raw commands map directly to the job, perfect for local file operations or text processing. It routes complex tasks to MCP when the job requires rendering, authentication, or strict access control. Efficiency comes from balancing the speed of high-speed execution against the security of server-managed instruction. Building systems that wield both protocols allows agents to select the most efficient path for every task. To see more practical AI architecture, subscribe for further engineering insights.